Alright, Assalamu alaikum. This is Talha bin Nadeem, and this is the third video lecture of the topic carburetors of internal combustion engines. And in the second video of this topic, we started off with the different operating conditions of the IC engine, and we discussed about the idling and starting condition in quite details, and about the air fuel mixture requirement, and what are the some deficiencies which needs to be overcome. What we discussed about these things in the last lecture. Then we also studied the cruising and normal power operating range. Then we moved to maximum power acceleration. We also discussed this graph that and we concluded it by saying that for starting of the IC engine, we basically require a rich air fuel mixture, and for the normal operating conditions we require best economy mixture. And also when we are accelerating our IC engine, or we are operating our IC engine at higher loads, then we require the best power output as well. So again we would be entering rich air fuel mixture into the IC engine. Then we discussed in quite details the basic components of the carburetor, and along with that we also discussed the principle of carburation. And then we moved towards we discussed some deficiencies in the elementary carburetor. In the last class I mentioned that we will discuss about some of the equipments, some of the accessories which are being employed in the elementary carburetor, in the modern carburetors, to overcome all the necessary load requirements, because because an elementary carburetor cannot overcome these deficiencies. So we have to add some accessories in order to overcome these deficiencies. So today we are starting with some of the accessories which we will discuss in today's class. First of all, we have a main metering system. This main metering system, we discussed this main metering system in the last class as well. This fuel metering orifice, which is providing the fuel from float chamber to the venturi throat, is the fuel metering system, because it is allowing only that much amount of a fuel about which the pressure difference between the throat and the float chamber is present, and obviously it won't be enough to operate the IC engine, for the better operation of the IC engine. So some other accessories are also being employed. So the main metering system must be compensated to provide essentially constant lean or stoichiometric mixtures over the 20 to 80% airflow range. Okay, next we have an idling system. Idling systems, as the name suggests, that when your IC engine is idle, in such cases your idling system will operate. And when your engine is idle, and or you can simply say when you are operating your engine on idling conditions, there is no load, you basically require a rich air fuel mixture to overcome the friction between the stationary components of an IC engine. and since the choke valve is slightly open and the difference between the pressure at the throat and the float chamber is not that much enough to take the desired amount of a fuel to the combustion chamber. So an additional system needs to be incorporated in the carburetor, and that system is called idling system. We can also see the idling system in this diagram as well. These connecting pipes which can be seen here is of an idling system. Okay, now here you can see is in an idling condition we basically what is happening here is that when your throttle choke valve is slightly open, so the lesser amount of the air is entering from the air filter to the venturi section, and only small, and in this section the small amount of a fuel would be entering from float chamber into the venturi throat, because there is not much pressure difference, not much carburetor depression present here. So we would be having some sort of a lean mixture, but during the idling condition we basically require a rich air fuel mixture. So in order to overcome that, we have provided this idling system. Now what will happen here is that some portion of the air will move into these air bleeds, idling air bleeds, and as it passes through the idling air restriction, and since the pressure at this point at the throttle valve is quite low, because the lesser amount of not that much amount of air is coming from the venturi section, it will allow the fuel to flow from float chamber through this idling passage, and it will mix with the air, with a small amount of air which has come from the idling air bleed, and then it will go towards this throttle valve, which will mix with the air fuel mixture that is coming from the main venturi jet. Ultimately it will be giving you a rich air fuel mixture, which is a primary requirement for the idling condition. So we can conclude idling metering system by saying that it is being employed to overcome the deficiency that your carburetor is not providing a rich air fuel mixture during the idling or starting condition. So your this additional idling system is providing that much fuel, so it is giving you it is providing you a rich air fuel mixture at the end of this at this point, and it will move to the intake manifold and then into your combustion chamber. Okay, so next we have power enrichment systems. So power enrichment systems are basically those systems, they are being employed when we want to operate these systems will be operational when we want to operate our engine at a high loads. So at high loads we basically require some additional fuel, we require rich air fuel mixture, and here you can see the power enrichment system. This here you can see that there is a plunger type valve which will be closed during the normal operation, but when you accelerate your car or your IC engine to the higher loads, this plunger is connected with that accelerator pedal via links, and when you have provided that much power, this link system will open the, it is being joined like this. This link system is basically opening this plunger, and then the fuel, some additional fuel will flow from this power enrichment jet and then into the venturi section, venturi throat. So it will give you the higher large amount of a fuel, or you can say higher fuel air ratio, rich mixture, so that you can operate your car or IC engine at higher loads. Okay, next we have the accelerator pumps. So the purpose of accelerator pump and enrichment system is quite a bit similar. The only difference is that accelerator pump usually operates when you have suddenly increased the loads, or you have suddenly pressed the accelerator pedal of your car because in that case the throttle valve has suddenly been opened and the large amount of air is coming from the venturi section, but due to the inertial effects of the fuel is not being the amount of a fuel is not being increased that much, that air is not taking out that much amount of a fuel. So instead of getting a rich air fuel mixture, you start getting lean air fuel mixture for a small duration of time, which will give which is not good for your IC engine. So in order to overcome this scenario, we have incorporated an additional device which is called acceleration pump system. This is a plunger type pump system, spring loaded plunger type pump system. This additional valve is generally under normal circumstances it will be filled with the fuel, and when you have accelerated your car with the help of this link system, it will move, this plunger will move downwards and it will force the fuel to move through these passages and then into the venturi throat, which will give you the additional amount of a fuel which is required for the acceleration conditions. And when the normal conditions are obtained, this spring will bring back the plunger back to its original position. So that's how you incorporate the sudden pressure, sudden load changes by incorporating an additional device which is called acceleration pump system in your carburetor. Next is a choke valve. Sometimes you require a lean air fuel mixture and your engine is not starting, therefore you basically rotate your choke system and then some additional amount of air goes into your system and ultimately it will combust the fuel, and then your bike or engine will start. Generally this problem occurs, choke is quite helpful in starting a motorbike. Then the next additional device which are generally being employed is altitude compensations. As we move to the higher altitudes, the density of the air increases. So the mass of air which is which is entered into the combustion chamber has also been increased. Ultimately, it will lead to the lean air fuel mixture. From the as we compare it with the normal operation, so we have to compensate these effects as well, and for that purpose the altitude compensators are being employed. Okay, moving forward, we have some additional compensating devices which are being incorporated in the elementary carburetor in order to ensure the proper operation of the IC engine, or to provide the desired air fuel mixture to your IC engine. An automobile running on a road has to run on a different loads and speed, especially on a city roads, especially like a city like Karachi, where we have a huge problem of traffic. One may be able to operate the vehicle between 25 to 60% of the throttle only. During such operation, carburetor must be able to supply nearly constant air fuel mixture, uh, which is also economical. However, the tendency of a simple carburetor is to supply the richer fuel mixture as the throttle valve starts opening. So the main metering system alone will not be sufficient enough to take care of such situations. Therefore, some additional compensating devices are need to be incorporated in your simple elementary carburetor. Some of the in the book we can see a lot of compensating device, but I'm just going to discuss some of the important ones here. First one is the air bleed jet. Okay, so in this air bleed jet, here you can see that there is an additional jet which is being named as, which is called restricted air bleed. So initially this main metering jet and this air bleed jet is filled with the fuel, and once you start your engine, then the fuel will flow here in the throttle valve, in the venturi throat, when the air passes through it, and the air will start flowing into this restricted air bleed jet, and it will mix with the fuel and will form an emulsion sort of a mixture, and then that mixture will come through the main jet into the venturi throat. So it contains an air bleed into the main nozzle. The flow of air through this bleed is restricted by an orifice. Here you can see that the airflow is being restricted by an orifice as well. When the engine is not operation, the main jet and the air bleed jet will be filled with the fuel. When the engine starts, initially the fuel starts coming through the main as well as air bleed jet, which I mentioned earlier as well. And when you increase the engine speed, now only the air will start coming from this restricted air bleed, and here it will start forming the emulsion of fuel and air, and that emulsion would be taken from this main jet to the venturi throat. So as the engine picks up, only air starts coming through the air bleed and mixes with the fuel, making an air fuel emulsion. Thus the fuel stream, which has become an emulsion of air and liquid, has negligible viscosity and surface tension. If the fuel flow nozzle of the air bleed system is placed in the center of the venturi, both the air bleed nozzle and the venturi are subjected to same engine suction, resulting in approximately same fuel air mixture for entire power range of operation. So as we were increasing the load, as we increase the load, as more the throttle valve is opened, the richer the air fuel mixture would be coming. So we want to provide a constant sort of a air fuel mixture. So we will incorporate these air bleed jets. I hope it is clear to all of you. Okay, so next, the another compensating device which are being employed in the carburetor is called compensating jets. So here you can see that this is your main jet, and along with this main jet we have another compensating jet. This valve is called compensating valve, and there is an orifice to restrict the flow from your float chamber to the compensating valve. And what is happening here is that when the air comes from the filters and choke valve to the venturi section, it will not only take the fuel from the main jet, but it will also take the fuel from the compensating jet. And since the diameter of the compensating jet is smaller than the diameter of the main jet, therefore it will be supplying a larger amount of a fuel. It will be supplying larger amount of a fuel when your engine has just started or your throttle valve or the air flow is small. So initially here in this graph, in this figure, you can see that when we have the low air flow rates, the flow from compensating jet is higher, whereas the flow from the main jet is lower, and that is because of the diameters of these jets, difference of the diameter between these jets. And as we increase the flow rate, air flow rate, the fuel supply from compensating jet will start decreasing, whereas the fuel supply from the main jet will start increasing. And the combined jet, however, the combined jet flow will more or less remains constant. That's what the purpose of compensating jet is, to provide a more or less constant air fuel mixtures for the various throttle valve opening from 20 to 80% approximately. Okay, the principle of compensating jet is to make the mixture leaner as the throttle valve opens progressively. In this configuration we have a compensating jet in addition to a main jet. Compensating jet is connected to the compensating valve here, and the flow is being restricted by the orifice valve. Compensating valve is supplied with the fuel from the main float chamber through a restricted valve. I have already explained this part. With the increase in airflow rate, there is a decrease in fuel level in the compensating valve, with the result that fuel supply through the compensating jet decreases. I have also mentioned that when you increase, when the air starts coming, the major portion of the fuel would be coming from the compensating jet, but as the flow progresses, the the contribution from the main jet for the supply of fuel would be increased, whereas the contribution from the compensating jet would be decreased. So compensating jet makes the mixture leaner, whereas the main jet progressively makes the mixture richer. The sum of the two tends to keep the fuel air mixture more or less constant throughout the different throttle valve opening. So I hope it is clear to you. It is clear that the purpose, we can conclude the compensating jet by saying that the purpose is to provide more or less the same air fuel mixture for the different loads or for the different throttle valve opening. Okay, next one is the emulsion tube. In this emulsion tube, here you can see that this main metering jet is kept approximately about 25 millimeter below the fuel level in the float chamber. Okay, so let's say here this is your float chamber level, and this is the point where your fuel. This is the point where your fuel metering jet is present, and you can clearly see that it is submerged in the fuel. That's why these tubes are sometimes, these emulsion tubes are also referred to as submerged jets. So okay, now what will happen here is, as the air starts coming, it will take the fuel through it, fuel along with it, and as the fuel is being taken, these tubes have a perforated holes. There are slight holes here, it can be seen. I'm highlighting these holes here. This is the hole, there are the holes. So here you can see it along the periphery, along the entire periphery of the tube. There are some holes in it, and as the fuel is being taken away by the incoming air, these holes will ultimately be uncovered. The fuel level will start dropping, and the fuel as the fuel level drops, these holes will be uncovered, and the air will now start moving through these uncovered holes into the main tube, where it will be mixed with the fuel, and thus forming a air fuel mixture, emulsion sort of a mixture. That's why these tubes are also named as emulsion tubes, because because air is forming an emulsion sort of a mixture inside the tube, and then this emulsion will again be mixed with the air outside this main metering jet, and would be providing you a lean air fuel mixture, or you can say it would be decreasing the richness of a mixture when the holes have been uncovered. So okay, now we will start. We will just go through the description here. In this configuration, main metering jet is kept at a level of about 25 millimeter below the fuel level in the float chamber. This is the level of the float chamber, and main metering jet is here. So there is a difference between the height of the. This is the level of the main metering jet. So this is the difference between the level of these sections, float chamber and main metering jet. The jet is located at the bottom of the well. The sides of the well have holes, and I have explained this part. I have shown you the holes where these red colors here you can clearly see. I have explained that section. These holes are in contact with the atmosphere. In the beginning, the level of the petrol in the float chamber and the well is same. So the flow level at the float chamber and the this well would be same initially. When the throttle valve is opened, the pressure at the venturi throat decreases and the petrol is drawn into the air stream. This results in uncovering the hole. When air is coming through the air filter, it will take some fuel and the fuel level will drop, and as a result these holes will be uncovered. So normal flow takes place from the main jet. The air is drawn through these holes in the well and the fuel is emulsified, and the pressure difference across the column of the fuel not as high as in the simple carburetor. Yeah. You can see that the fuel will enter in this tube, air will enter in this tube, and it will be mixed with the fuel, forming an emulsified air fuel mixture, and then again it will flow towards the other end of the main jet, and it will be mixed with the air, and then it will go towards your intake manifold and then to your combustion chamber for combustion. So we have studied three compensating devices, additional compensating devices which are being incorporated in the modern carburetors. We started our lecture today with some additional equipments which are being incorporated in the modern carburetor, like main metering system, idling system, power enrichment system, accelerator pump, choke valve, and altitude compensation. We discussed these diagrams, and then we started off with some additional compensating devices which are being incorporated in the modern carburetors, and we discussed the air bleed systems, compensating jet, and the emulsion tube as well. So we will end the accessories topic here. Now moving towards the last topic of today, and that is the some basic types of the carburetor, depending upon the which are being based on the direction of the flow. So here you can see we have three basic types of a carburetor. First one is updraft, then the downdraft, and the third one is cross draft. So here, and I have also mentioned the figures, the diagrams of these types of carburetor here as well. So here you can see updraft. In this updraft type carburetor, the air is flowing from bottom, and then it will go to the upward section, and then into your intake manifold and the combustion chamber. So here you can see that the air is taking the fuel along with it, and it is happening because of the air friction. So the air friction should be that much that it will take the air friction should be that much that it will take the fuel along with it. And so these Because of this phenomena, because of this restriction, because of this arrangement, this flow of air, they are being restricted to lower speed engines. On the other hand, if you look at this downdraft engine, downdraft carburetor, air is flowing from top and it is taking fuel along with it. So the fuel will, air is taking the fuel. In this arrangement, the air friction is, fuel is not being taken by the air friction. In fact, it is being taken away by gravity. So in the downdraft carburetors, what we basically arrange the carburetor at a higher level as compared to the intake manifold, so that by gravity it will allow the fuel air mixture to travel into the intake manifold. And then we have this cross draft carburetor. Here you can see air is traveling from left side to right side and it is taking fuel along with it. So we basically get the advantage, the lesser pressure drops occur in the cross draft, and that is the advantage of the cross draft carburetors. Okay, we will just go through the details of this updraft carburetor. I have already explained it, but we will just go through the details. In these carburetors, air enters at the bottom and leaves at the top, so that the direction of its flow is basically upwards. It is coming from bottom and then it is going from the top and taking the fuel along with it. So direction is upwards. The disadvantage of the updraft carburetor is that it must lift the sprayed fuel droplets by air friction. I mentioned this part earlier, that air friction is responsible for taking these droplets of air along with it. Hence, it must be designed for relatively small mixing tube and throat, so that even at low engine speeds, the air velocity is sufficient to lift and carry fuel particles. Again, we have a design restriction over here, that we have small throats and small mixing, small size of mixing tube. Therefore, these engines cannot be incorporated for the high speed engines. They are generally designed for the low speed engines. Otherwise, the fuel droplet tend to separate out, providing only a lean mixture. Okay, next we discuss the downdraft carburetor. Air is coming from the top and then going from the bottom and taking the fuel along with it. It is a process that it is placed at the higher level than the intake manifold. I mentioned that part earlier, that the downdraft carburetors, since the fuel air is taking the fuel along because of the gravity, so they are being placed at the higher level as compared to the intake manifold, so that the air takes the fuel along with it. It is placed at higher levels than the intake manifold, and in which air and mixture generally flow a downward course. Here the fuel does not have to be lifted by the air friction, because fuel is being traveling due to gravity, as in the updraft carburetor, but move into the cylinder by gravity even if air velocity is low. Hence the mixing tube and throat size can be made larger, resulting in the higher engine speeds and higher specific outputs as well. So as I was mentioning earlier, that the upward carburetors are being restricted for low power engines, low speed and low power engines, whereas downdraft carburetors can be used for high speed and high power engines. If you have a large engine, then it is a probability, it has a more chances of having a downdraft carburetor instead of having a updraft carburetor. Okay, in the last we have a cross draft type carburetor, and in this cross draft type carburetor, the air, we have basically a horizontal section and air is coming from left side and going towards the right side and taking the fuel along with it. So it consists of a horizontal mixing tube with a float chamber on one side. By using cross draft, yes, I mentioned earlier that part as well, that by using this arrangement, this horizontal, this cross draft arrangement, resistance to flows has been decreased because of the elimination of some inlet passages, some additional inlet passages. The resistance to flow has been reduced. So the pressure drops in these carburetors are relatively lower as compared to the previous two. So okay, so far we have, so today we basically discussed, we started off with some of the we started with some modern carburetor designs, and we discussed some of the additional accessories which are being incorporated in the modern carburetors. Then we moved towards some of the additional compensating devices, and I mentioned that there are many compensating devices which are being mentioned in the book, but we are only going to discuss some of them, and we discussed 3 of these devices. First one was air bleed jet, second was the compensating jet, and the emulsion tube. So I hope the concept of these additional devices are clear. Air bleed jet basically provides the linear mixture at higher speeds when you are operating your engine at higher loads, when your throttle valve is open. So more fuel would be coming along with the from the main jet, but instead of providing only fuel, we have also added some air bleed section here, which will be giving some additional fuel to the main jet, making an emulsion, and thus it will reduce the richness of the mixture. And then we had the compensating jet. We discussed this as well, that at the starting of your engine, compensating jet will provide the major portion of the fuel, main jet will provide the lesser portion of the fuel. But as the throttle valve opens progressively, then the fuel flow from the main jet will increase, while fuel flow from the compensating jet will decrease. But however, the amount of a fuel of this combined jet would more or less remain constant. So ultimately it will be providing you a constant fuel air mixture for different throttle valve opening. Then we discussed the details of emulsion tube, and in the last we discussed the types of 3 different types of a carburetor based on the direction of the flow. So I hope these concepts would be easy to understand, and you wouldn't be facing that much problem. But in case any of you is facing any problem, you can contact me anytime, and we would also be having some online sessions for online question answer session. And apart from that, you can always contact me for the in case you have any query. In the next class, we will do the derivation of this topic of carburetor, and then some problems as well, and then we will conclude this chapter and move towards the next topic. So that's it from my side today. I hope things are clear to you. In case in any query, you can always contact me. Okay, Allah Hafiz.